Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is Edexcel 2021, Paper 2, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. Write 31% as a fraction. Well, 31% literally means 31 out of 100. So that's pretty easy really, isn't it? 31 over 100. Question 2. Change 3 meters into centimeters. Well, 1 meter is how many centimeters? It's 100 centimeters, isn't it? So if I've got 3 meters, it's going to be 3 lots of that. It's going to be 300 centimeters. 300 centimeters. Question 3. Write the following numbers in order of size. Start with the smallest number. Okay, and I've got 1.02, 0.12, 1.20 and 0.21. Okay, now you need to compare like with like. So if we're looking at the first digit of each number, the first unit number, isn't it? The ones column. You can see some of them are ones and some of them are zeros, and obviously the smallest ones are going to be the ones that start with 0. So it's going to be out of these two here then, isn't it? Which one is the smallest out of these? So I know it's going to be one of these two. Let's have a look at the next digit along. Next digit along, I've got a 1 and a 2. So we're going to pick the one with the smallest digit, and that is 0.12. So 0.12 is the smallest, and then 0.21 is the next biggest. Okay, let's look at the second digit of our numbers that start with 1. I've got 0 and I've got 2. So again, picking the one that's got the smallest digit first. 1.02 is next and 1.20 is last. Okay, so 0.12, 0.21, 1.02 and 1.20. Question 4a. Simplify m plus m plus m plus m. Right, when you've got 4 m's, you've got 4m, haven't you? That's 4m. B, simplify 12p divided by 4. Well, I just need to, 12p divided by 4 is this, isn't it? It's this. I'm just going to cancel the 4 into the 12. It's going to leave me with 3, 1, so that's just equal to 3p. 3p, and that was 4m, wasn't it? Question 5. The diagram shows a rectangle. It's 20 meters by 35 meters. On the centimeter grid below, draw an accurate scale drawing of the rectangle. Use a scale of 1 centimeter represents 5 meters. Okay, so we're going to have to take each one of those lengths then and divide it by 5 and then switch it from meters into centimeters then, aren't I? Okay, so how many times does 5 meters go into 20? It goes in 4 times. So this one I'm going to use 4 centimeters to represent 20 meters. 5 goes into 35 7 times, so I'm going to use 7 centimeters to represent that 35 meter length there then. Now luckily the grid is already in centimeters because you can see my magical digital ruler doesn't have any real numbers on it, so I'm just going to use the grid here to help me. So I need to go 7 units in this direction. 1, 2, 3, 4, 5, 6, 7. Change direction, and we're going to go down 4. 1, 2, 3, 4 in that direction. 4 in this direction as well. And then just join it back up. Okay, so there's my rectangle drawn to scale. Question 6. Here is a list of whole numbers from 21 to 30. From the list, write down a square number. Well, square numbers are numbers that you times by themselves, and then that's your square number then, isn't it? So the first square number is 1. 1 squared is 1. That isn't on the list. Next square number is 2 squared, which is 4. Then I've got 3 squared, which is 9. 4 squared, which is 16. 5 squared, that's 25. Now that one is on the list. Okay, it's here, look. So I think it's going to be 25. Now the next square number after that is going to be 6 squared, which is 36, which is too big, isn't it? It's off the list. And then part B, from the list, write down a multiple of 8. Well, the multiples of 8 are 8, 16, 24, 32. And the only one that's on the list then is the 24. Okay, so that's the one I'm going to pick. So 24. Question 7. A baker has 3 bags of flour, A, B, and C. Bag A and bag B contain the same amount of flour, and bag C contains 940 grams of flour. In the 3 bags, there is a total of 2,500 grams of flour. Work out the amount of flour in bag A. Okay. Now, I like to use algebra when I have values that I don't know from the start. So bag A, I don't know the weight in bag A, so I'm going to call it X. But I do know that bag B contains the same amount of flour as bag A. So that one then is also X. Okay, and then I've got the 940 grams that are in bag C. So if I took the weight of A and B and C and I added it together, I'm going to get my X value plus X value plus 940 grams. And if I add those 3 things together, I'm told that that equals 2,500 grams, doesn't it? 2,500. Okay? So just collecting those like terms together. So X plus X, that's the same thing as 2X. So 2X plus 940 is 2,500. Taking 940 away from both sides, they're cancelled from that side. And then 2,500, take away 940. You can tap that into your calculator like it, or just do it freehand. I make that 1,560. That's going to be equal to 2x. Okay, and then dividing both sides by 2. It's going to leave you just with x. X is equal to half of 1,560, which is 780 grams, then, isn't it? So, how much is in bag A? Bag A contains 780 grams. Okay. Question 8. 5 students throw a dice. They each throw the dice the same number of times. The diagram gives information about the number of times the dice lands on each number. And you can see we've got a line graph here. It's got the number on the dice along the bottom, and you've got the numbers 1 through 6 and the frequency up the side. So we should be able to read off the frequency for each outcome from the frequency table quite easily. So we got out the scores 1, 2, 3, 4, 5, 6. So for 1, look, that's that bar there. You can see it's got a height of 6. The second bar has got a height of 4, look. So that's 4. The third bar has got a height of 5. So that's 5. The fourth bar has got a height of 8. 8. And the fifth bar has got a height of 7. 7. And the sixth bar has got a height of 5. Look, so 5. Okay. Now I want to know how much that adds up to, so I'm just gonna add that up then. 6 plus 4 is 10, plus 5 is 15, plus 8 is 23, plus 7 is 30, and plus 5, that adds up to 35. So there were 35 throws altogether. Now remember there were 5 students, so if there were 35 altogether, and we know that each student threw the dice the same number of times, then each student would have thrown the dice 35 divided by 5 times, which would have been 7 times. Okay, so each student would have thrown the dice 7 times. 7 times 5 is 35. 35 throws altogether. Question 9. Alec needs to work out the value of 2 plus 3 times 4. He writes 2 plus 3 is 5 and 5 times 4 is 20. So 2 plus 3 times 4 must be 20. Alec is wrong. Oh yes, he is. Explain why. Well, he has done this first, isn't he? He's added these two together first, and then he has multiplied by 4, which is against the rules of what? BIDMAS. Brackets, indices, division, multiplication, addition and subtraction. This little word dictates how we're meant to approach order of operations. And there are no brackets, and there are no indices, and there are no division, but there is multiplication in this, and there is addition. Okay, now multiplication clearly comes first in the BIDMAS list, so you can't add 2 plus 3 first and then times by 4. You got to do the multiplication first. So why is he wrong? Alec is wrong because he has not followed BIDMAS. And I might just, it's probably not necessarily, but I might just show what the correct calculation should be. So 2 plus 3 times 4. You're meant to do this bit first, aren't you? You're meant to do the multiplying first. So that's 2 plus 12, and then 2 plus 12 you then add together, and that is going to give you 14. Okay, so I'm just going to include that as part of my reasoning. Yeah, but it's only 1 mark, it's probably not required. Question 10, write 17 as a fraction of 30. Really? 17 as a fraction of 30. I've done it. Is that even a question? Question 11, reflect the shape A in the mirror line. When you're reflecting shapes, don't try and reflect the lines. Reflect the vertices or the corners of the shape. This shape has got 3 vertices, here, here and here. Now what I like to do is I want to count how far away each one is from the mirror line and then reflect it that amount of points on the other side. So if you have a look at this one on the right, that lies 2 units away from the mirror line. So its image point is going to be another 2 units away on the other side. So its image point is going to be here, look. Okay. If I do the same thing with the other ones, look, this one is 3 units away from the mirror line. So its image point is going to be 3 units away as well. It's going to be here. And then finally, the other one there is 4 units away, so its image point is going to be 4 units away. It's going to be there. Now, once you've reflected all the shapes, then you can join them up with your ruler to create the actual lines of the shape. Okay, now it's much easier to do that than trying to reflect the lines. If you try and reflect the lines, you're going to go wrong. Okay? So we normally label images of things the same name, the same letter, but with a little dash like that. So the image of A is A dashed. Okay, so I'm done. Question 12a, work out 13.82 divided by 4.06. Okay, write down all the figures of your calculator display. So we're just going to type into the calculator 13.82 divided by 4.06. That comes out to be, that's interesting, it's got a little dot on the first one. My calculator does a lot of digits. This is really long. 3.4039 408866995. God, so long. Why does my calculator do so many digits? 073891625. They're having a laugh. How long does this thing go for? I didn't realise my calculator had so many displays. So 56157 635. I'm running out of space. 46. What goes on forever? I'm not writing all that down. Seriously? Oh, it's got a real dot in the end. I'm not writing all that down. No, I haven't got any space. So it's obviously a recurring decimal with about a bazillion digits in it before it recurs. I think I've written down enough. They can't seriously want me to write down more than that. It was about 50 digits. So anyway, give your answer to part A correct to 2 decimal places. Okay, well the first decimal place is here and the second one is here. This is going to be a little bit more succinct if I'm going to round off after that point there. Then the next digit, look, is a 3, so that means we're going to be rounding down. So it's going to stay as 3.40 then. So 3.40 to 2 decimal places. Okay, good. Yeah, I ain't writing down all those digits. Question 13. RST is a straight line. Work out the value of x. Okay, well if I've got 3 angles on a straight line, then they've got to all sum to 180, haven't they? Because they all add up to a straight line, which is 180 degrees. So x plus 75 plus 84 added together is going to give me a straight line of 180 degrees. Okay, so adding the numbery bits together. So 75 plus 84, what's that, 159? 159 plus x is 180. Let's take 159 away from both sides. Okay, so from this side they cancel. And over there, 180 take away 159 leaves 21, doesn't it? So that leaves me with x is equal to 21 degrees. So that's my answer, 21 degrees. Give a reason for your answer. Angles on a straight line sum to 180 degrees. So you need to know all of these various angle rules so you can write them down. They love to put these extra reason questions at the end, so you do need to kind of have all those kind of committed to memory. Question 14. Nazima uses this graph to find out how much money she is paid for a number of hours she worked. And so we've got hours worked along the bottom and we've got her pay along the side. So it's a conversion graph, isn't it? So how much money is Nazima paid for each hour that she works? Now we can work that out by kind of looking up from 1 hour then, can't we? If we look up from 1 hour, we'll work out how much she gets paid for 1 hour. So let's read up from 1 until we hit the graph, and then we're going to spin around and go the other way. It's a good idea to show your method on the graph like this. So it's kind of pointing, it's kind of halfway between that little square there, isn't it? Now I've got like 5 divisions between 10 and 20. So each division is worth 2. So I think there are 2.5 divisions, and that's going to be worth 5 then. So I think that's pointing at 15. So how much money is Nazima paid for each hour that she works? She's paid £15 an hour. Okay. Last week Nazima worked for 36 hours. How much money was Nazima paid? Okay, so this graph isn't going to do us very much good, is it? Because it runs out at 5. So no good at all. So let's reach for the calculator instead. So if I've got £15 per hour for 36 hours, then Let me just write that down, because if you type something into the calculator, you should really write it down, shouldn't you? So wages equals 15 hours at, sorry, 15 pounds times 36 hours, and that comes out to be 540 pounds. Okay. Question 15, write the following fractions in order of size, starting with the smallest fractions. Now, actually, fractions are pretty difficult to compare in size when they've got different denominators. If this was the non-calculated paper, I'd probably want to rewrite them all as with a common denominator. But this is the calculated paper, so I think the easiest thing to do is just going to be to rewrite these as decimals. So I'm just going to type the fractions into the calculator and get it to convert into a decimal for me. So 5 divided by 8, according to my calculator, is 0.625. 0.625. 2/3. Now that's going to be a recurring decimal, isn't it? It's 0.6 with a dot on it, which is actually 0.666. I'm just going to write all those digits down because I want to be able to compare it with the others easily enough. 4/9, so 4 divided by 9. Again, I think that is a recurring decimal. That's 0.444, isn't it? So that's going to be 0.444. I'm going to just put a little dot on the end there. I wanted to show more digits so it's easier to compare. And then 3/5, that's a bit of an easier one. That is 0.6. Okay. This time I'm going to just put some zeros on. So I've got the similar number of digits for all of them. Okay. So now I've got them all written down like that. I hope you can see that the smallest one is going to be this one here, because that starts with a 0.4. Okay, so that's the first one. That is the smallest. I'm going to start with 4/9. Okay, now all the others start with 0.6, 0.6, 0.6, 0.6. So let's have a look at the next digit along. That's got a 0, that's got a 6, that's got a 2. So the smallest one then is going to be that 3/5. 3/5 is next. Okay, then the next biggest one is going to be the one with a 2 there. So that's 5/8. 5/8 is next. And then finally the 2/3 is the biggest one. Okay. Question 16. The pie chart gives information about the color of each car in the car park. So you can see the most common color is black. There's a right angle in there, so that's like 90 degrees, isn't it, that one? And then white is 80 degrees, and other colors is the rest. Okay. Now there are 135 black cars in the car park, so this black section is equal to 135 cars. So then we need to work out the number of white cars in the car park. Well, if you have a look at the black section, that is 1/4 of the circle, isn't it? So if 1/4 gives you 135 cars, then the total number of cars, then you're going to multiply by 4 then, aren't you? So if I multiply this by 4, then all of the cars is going to be 135 times 4 then. So 135 double is 270, double again, that's 540. So there are 540 cars altogether. So then what fraction of those are white cars? Well, the angle in the center here is 80 degrees. And in a full circle, I've got 360. So the number of white cars is going to be equal to that angle at the center over 360. That's the fraction of the circle that is represented by white cars, times by the total number of cars in the car park, which is 540. That should give me the number of white cars. Okay. So I'm going to type in 80 over 360 times by 540, and that comes out to be 120. So work out the number of white cars in the car park. There are 120 cars. Okay. Now part B says there are 50 grey cars in the car park. A car in the car park is picked at random. Find the probability that this car is grey. Okay. Well, the probability of any event is equal to successful outcomes divided by total outcomes. So the probability of getting a grey car, success would be picking one of the grey cars, of which there are 50. And then how many cars are there altogether? There is 540 cars. So the probability of there being of picking a grey car is 50 over 540. Now there are never any marks for cancelling down these fractions. I mean, you could type it into your calculator and cancel it down. So that's 5 over 54. It just divides by 10. Should have known that. But actually, I've never seen marks awarded for cancelling down like fractions in probability questions. So by doing so, you're going to gain nothing, and you know, if you make a mistake, you're going to lose a mark. So it's probably best not to bother. Question 17. 60 people are asked if they prefer to text or email their friends. 38 of the people are women and the rest are men. 15 of the men prefer to email their friends. 60% of the people prefer to text their friends. Complete the frequency tree for this information. Okay. So you can see we've got 60 here, and then the first division is into men and women. And do we know anything about that? 38 of the people are women, okay, and the rest are men. So that we can fill this in then. So women is 38, so 38 goes in here, and men is got to be the rest then. So what's 60 minus 38? That is 22, so there must be 22, okay, because the men and the women together must add together to give you 60. Okay, so we dealt with that bit. And it says 15 of the men prefer to email their friends. So from the men, from those 22 men, then 15 prefer to email. So that means I can write 15 in here then. So how many must prefer to text? It's got to be the rest of them. So 22 take away 15, that leaves me with 7. So it's got to be 7 up there. Okay, so we've completed the men branch. Now, finally, it says 60% of the people prefer to text their friends. Okay, so 60% of all of the people. What is 60% of all of the people? I'm just going to do a quick triangle here. Final, original, multiplier. FOM. Stick your thumb on it. Okay, this is how I'd like to do my percentage questions. What is the final? That is what I want to find. What is the original? I've got 60 people I want to find a percentage of. And what is the multiplier? Well, I want to find 60%, which as a multiplier is 0.6. Okay, so I want to find the final, so let's cover that up. That tells me that the final is equal to the original times the multiplier. Final equals original times multiplier. Okay, which is 60 times 0.6. So according to my calculator, 60 times 0.6 comes out to be 36. So that means 36 people altogether like to text. Okay, so if 36 people prefer to text, we've already accounted for 7 of them here, haven't we? There are already 7 men who like to text. So women who like to text is going to be equal to that 36 people who like to text minus the 7 men who like to text. That leaves me with 29 women who like to text. Okay, so that means that number there is 29. And then what's left for email is going to be the rest, isn't it? 38 take away 29. That leaves me with 9 there. Okay, so all the bubbles are now complete. We're done. Question 18. The incomplete table gives some information about the lengths of the planks of wood in Ben's workshop. We've got length of plank in meters. They go from 3 to 2.5 to 2 to 1.5 to 1. And we've got some planks, 5, 8, blankety blank, 14 and 10. Okay, we're told that the total length of all these planks is 92 meters. Work out the number of planks of length 2 meters in Ben's workshop. Okay, so that blank in there doesn't mean we haven't got any. It just means we haven't found it yet. We need to go and find that value there. Okay. Now, if I've got 5 planks and they are of length 3 meters each, then the total length of those 5 planks I'm going to get by multiplying those together. Okay, so I'm going to make a new column called total length. You can use a ruler. I don't need to, I'm on a computer. Okay, so 3 times 5 is 15. Okay, so those 5 planks have a total length of 15. And I'm going to do the same thing. I'm just going to multiply all these on the way down. I can't do that one, but I can do this and I can do this. Okay, so 3 times 5 is 15. 2.5 times 8, so that's 8, 16, 20. Comes to 20. Blankety blank one I don't know yet. 1.5 times 14, that's going to be 21. And 1 times 10 is 10. Okay, now I know that these should all add up to 92 meters. So the total here should be 92. But what does it add up to? 15 plus 20 plus 21 plus 10. That actually adds up to what? 15 plus 20 plus 21 plus 10. That actually adds up to 66. Okay, so then we've got some missing wood here, haven't we? So missing wood is going to be the 92 meters we're expecting minus the 66 meters we've accounted for. So what's the difference there? So 92 minus 66. That means I've got 26 meters missing. Okay. So now each one of these missing blankety blank ones that we need to find is 2 meters. So if we take the missing wood and we divide it by 2, that gives us 13. So that is the number of planks of the 2 meter planks that we're looking for. There are 26 meters altogether. Divide by 2, that gives me 13 planks. Okay, so there should be 13 in there. Okay, so work out the number of planks of length 2 meters. There are 13 planks. Question 19. Rachel, Samina and Tom share £600 between them. Rachel gets 2/5 of the £600. Samina gets 1/4 of the money that's left over. Tom gets the rest of the money. Tom says, I would have got more money if we had shared the £600 equally between us. Is Tom correct? You must show how you get your answer. Okay, let's figure this out. Rachel gets 2/5 of the £600. So what is 2/5 of £600 then? Okay, 600 times 2/5. That comes out to be 240. So she gets 240. So what's left? So then 600 minus 240. That leaves me 600 minus 240. That leaves me £360 left to share between Samina and Tom. Okay, so what does Samina get? She gets 1/4 of the money that's left. So 1/4 of 360. What's that then? 1/4 of 360. That comes out to be 90. So what's left over for Tom? So Tom is going to get 360 minus the 90 that we give to Samina. So that leaves him with 270. Okay, so Rachel to Samina to Tom. Rachel, we said, got 240. Samina got 90. She got a bit stiff there. And then Tom got the rest. So he got the most. He got 270. Okay. Now, is that more or less that he would have got if they'd have just shared it out? Okay, so sharing equally would have been £600 divided just by 3 of them. That would have been £200. So you can see actually Tom is better off. So is Tom correct? Tom is wrong. He receives £70 more. Okay, so he receives £70 more than he would have done if he'd have got a third. Question 20, simplify c to the power 5 divided by c squared. Okay, now this is a laws of indices question. I've got two numbers with the same base that I'm dividing, so I'm just going to subtract one index from the other then, aren't I? So c to the 5 divided by c squared is going to be c to the 5 take away 2, that's c to the 3. Okay, c to the 3. Simplify d to the power 4 raised to the power 3. So when we've got a base raised to an index and that whole thing is raised to another index, we call this an index of an index. And what we have to do then is multiply those powers together. So this is going to be d to the power of 4 times 3, which is d to the power of 12. Now if you think about it, if you cube something, you times it by itself. So you'd be timesing d to the power 4 times d to the power 4 times d to the power 4. Adding up those powers, you can see you're also going to get 12. So you could do it that way as well. D to the power of 12. Write down the inequality shown on this number line. Okay, well you can see we've got an open circle at -1, okay, and then an arrow pointing off to the right, which means that our value of x is going to be bigger than -1, isn't it? So x is greater than -1. Now notice this has got an open circle at this end. That means it is strictly greater and not greater than or equal to, so it can't actually be equal to -1. So it's x is strictly greater than -1. For B, it says on the number line below, show the inequality -3 is less than or equal to y, which is less than 4. So again, we're going to have two circles on our number line, one at -3 and one at 4. And then these are going to be joined up with a straight line because y is going to be between those two endpoints. Okay, and finally we need to think about whether or not the endpoints themselves are included in the range. With -3, y is greater than or equal to -3. That means it can be -3. So in order to show that, we shade this one in, we fill it in. Okay, so it's kind of like a solid circle on this end, because -3 is part of the region that we want. Now on the other end, we've got that y is strictly less than 4, so it can't actually be equal to 4. So again, just with the same as part A, we show that one as an open circle. Okay, so that's that one. Find the highest common factor HCF of 60 and 84. Okay, now there are different ways of doing highest common factor. Probably the most simple to explain is the exhaustive search method, and that's where you find all the factors of both your numbers. So like all the factor pairs of 60, like 1 and 60, 2 and 30, and so on. Okay, that's one way of doing it. But when you've got large numbers like this, I actually think it's probably easier to use prime factor decomposition, or use product of prime factors, another way of saying it. So in order to do that, you need a calculator, a Casio one preferably, because that's got the feature on it. And then you type into it 60 equals, you need to press the equal button for it to work, and then shift, and then this fact key here. And this will tell you what the number is as a product of its prime factors. I think it's easy, it will give it to you in index form. I think it's easier just to expand it to find HCFs though. Okay, so that's 2 times 2 times 3 times 5. And then 84 equals shift fact. That's 2 times 2 times 3 times 7. Okay, so then the HCF is going to be made up of all the factors that are common to both. So I've got a 2 in both, a 2 in both, and a 3 in both. I've got a 5 in one and a 7 in the other, so they're not common. So we take all the ones that are in both, like the 2, and the 3, multiply it together. 2 times 2 is 4, times 3 is 12, and that would be the HCF. So the HCF of those two numbers is 12. Okay. Find the lowest common multiple of 24 and 40. Now similarly, there is a method for doing this just by listing out all the multiples. So you can do 24, 48, and so on, and just kind of list them all out and see if you get one on both lists. So you go up from 40 as well, 40 and 80 and so on. So a kind of similar sort of exhaustive search. Alternatively, again, you can use product of prime factors here as well. So again, if I put 24 and 40 and I type 24 equals shift fact into my calculator, that gives me 2 cubed times 3. 2 times 2 times 2 times 3. And the other one, 40 equals shift fact. That's 2 cubed times 5. 2 times 2 times 2 times 5. And then, so as before, the ones that are in both kind of form the HCF. Now the LCM ones you can do in one of two ways. Probably the easiest one to explain is to just draw a Venn diagram. So this is for 24's prime factors, and this is for 40's. Drop in the numbers that are in both in the middle, 2, 2, and 2, and put the factors that are not in both on either side. So the 3 is going to go here and the 5 is going to go here. So once you've got all your numbers in the Venn diagram like that, then the LCM is just going to be all of those numbers multiplied together. So 3 times 2 times 2 times 2 times 5. So what's that then? 3 times 2 times 2 times 2 times 5. That comes out to be 120. Okay? So that's the way to do it with prime factor decomposition. Like I say, you could also just carry on with this list and get to 120 on both lists. That is a perfectly acceptable way of solving it. Which one is quicker or which one is best? It's hard to tell really. Sometimes it takes quite a while to find an LCM just by listing them all out. It could be there for a while before you find one on both lists. So I would say as the numbers get big, and particularly if they're large and close together, then doing it with prime factors can be a lot quicker. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. Okay, we've got a little stumpy graph here. Work out Sam's speed in kilometers per hour for the first 15 minutes of his journey. Now, speed can be found by looking at the gradient of a distance time graph, okay, because speed is the rate of change of distance with respect to time. So if I can find the gradient of that line, I should know what the speed is. Okay, so just going to kind of get a ruler out, just draw a little triangle here. Okay, and then we're going to look at change in y divided by change in x. Okay, so change in y, the difference between the y coordinates is going from 20 down to 0. So that's a distance of 20, isn't it? And then the change in x, I've got from 10 o'clock to 10:15. Okay, now presumably this is in kilometers per hour. We need to do it in. Yes, so I'm not going to write, rather than writing 15 minutes, I'm going to convert that into a quarter of an hour then. So a quarter of an hour. Okay, that's the same thing as 15 minutes, isn't it? So then the speed then is going to be change in y, which is 20, divided by change in x, which is a quarter in hours, a quarter of an hour. But if you think about it, dividing by a quarter is the same thing using keep change flip as times in by 4, which is going to be 80 then, isn't it? 80 what? 80 kilometers per hour. Part B says at 10:15, Sam stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometers per hour. On the grid, complete the travel graph for Sam's journey. Okay, so he's stopping for 10 minutes. So if he's stopping for 10 minutes, he's not moving anywhere, is he? Okay, so for this section then, it's going to be flat for 10 minutes. So from 10:15 through to 10:25 then, he isn't going anywhere. So I'm just going to draw a kind of flat line between there and there. Okay, and then maybe I'll do it in green so it stands out a little bit more. Let's just try that again. Does that stand out a bit more? Hope so. So yeah, from 10:15 to 10:25 he's standing still, and then for 20 minutes after that, which will take me to 10:45, then he is going to be traveling at 75 kilometers per hour. Okay, so how steep is that going to be then? It's a bit hard to use the gradient of 75 here because the graph doesn't go up that long and we haven't got hours on there anyway. I suppose we could scale the gradient down a little bit, but I think probably the easiest way of doing it is just do a quick distance, speed, time calculation, DST. So using the DST triangle, let's just work out how much distance he can travel in 20 minutes. Okay, so distance is what we're trying to find. Speed we know is 75 kilometers per hour, and time is 20 minutes, which is 1/3 of an hour, isn't it? Okay, so then distance, cover up what I want to, so distance is what I'm trying to find, so cover up D, so that tells me what to do with the other two. It's speed times time. So distance equals speed times time, which is 75 times 1/3, or in other words, 75 divided by 3, isn't it? So that is 25 kilometers then. Okay, so I know then in 20 minutes he's going to go 25 kilometers. So I can come along to 10:45, which is 20 minutes later, and I'm just going to go up 25 kilometers up my scale. So I'm currently at 20, so if I add on 25, that's going to take me up to 45. So I'm going to have a point then here, which is at 10:45 at a height of 45. And I'm just going to then join that up with a straight line. Okay. So then that's my completed travel graph then.
Complete the table of values for y equals x squared minus 2x plus 2. Okay, now this is a calculator paper, so this is very much a job for the calculator, and in particular the table mode. So if you press the mode button on your calculator and go into table mode, which is option 3, you should get a f of x equal appear on the screen. Now f of x is equal to is the same thing as y equals to. So what we need to do is to tap this equation into the calculator after that. So now notice that we need to start with an x squared, and there's a little x in red above one of the brackets. Press the alpha key, I can access that little x there. So x squared minus 2, alpha key again to get the x again, plus 2. Okay, so you can see x squared minus 2x plus 2 on my screen, the same as what's on the paper. Press equals. Now if you've got the latest Casio, it's going to ask you for g of x here. We don't need a second function. This table has the ability to do 2 functions at once, but you only need 1. So just press equals again to skip over that. Now the start value, that's going to be our lowest value of x here. So we need to start at -2. So -2. End value, well, that's going to be up at the other end. We're going up to 4, aren't we? So our end value is 4. Step, what we're going up in here. Now, if you have a look at the x values, they are going up in ones, aren't they? Add 1, add 1, add 1. We're going up in ones. That's the step. So we're stepping up in ones. Okay. Now, if I press equals again, it's going to create a table for me. And you can see I've got x values and y values here. So when x is -2, you can see on the table here, I've got y is equal to 10, or f of x is equal to 10. Okay, and now that matches up with my value that I've got down here, isn't it? So I've already got that one down there, so that matches. Next, I've got -1. That goes with 5. So I'm going to write my 5 here on the table. Next, I've got 0 goes with 2. Again, that's already on the table there. I've already got 2. So that gives me a bit of confidence. Going down a bit more, I've got 1 and 1. So let's write the 1 in. Then I've got 2 and 2. So let's write that in. And then 3 and 5. Again, I've already got that one on my table. So it's all matching up. So it's all good. And then finally 4 and then 10. Okay. Now you could just take these values of x and sub them into the function one after the other to generate the numbers, but the table function does it really, really quick, and you can just get all the values out really easily. So that's a really straightforward, easy 2 marks if you use the table function. Right, on to part B. On the grid, draw the graph of y equals x squared minus 2x plus 2 for values of x between minus 2 and 4. Now notice this is the same function as we had in part A. So basically we're just plotting the same points. Now each pair of values that we've got here in the table is going to be a coordinate that we need to draw on our graph. Now I've gone ahead and plotted the points and joined them up with a nice smooth line. When you're drawing your curve, it's important to make sure you skewer each of the points. So you want to go through each of the coordinates you marked and make sure you're just using one line. Some people kind of feather and they kind of have a couple of goes at drawing a curve and end up having multiple lines on their graph. That is not what you want. Okay. Also, this is a quadratic curve, so you're expecting it to be the shape of a parabola, aren't you, with a line of symmetry going down the middle. That is a classic quadratic curve parabola. It's called parabola. So that is what you're expecting to see. So that is the shape that I've got, so I'm pretty confident I've done it right. Now, if you've got a point that's lying off of that shape, then you've probably made a mistake on that point, so you just want to go away and check that again.
Finally, part C says use your graph to find estimates of the solutions of the equation x squared minus 2x plus 2 is equal to 4. Now note again, this is the same equation as parts A and B, so we're not having to change it in any way. We just want to know where this graph is equal to 4. Now the easiest way of doing this is just to draw a line at y is equal to 4 and see where it crosses our existing line. Okay, so I'm just going to draw a line at y is equal to 4, across like that, and you can see that then my lines intersect here and here. Okay, so reading down to the y-axis from those points. Okay, so I think this is quite good method. Let's try and get an accurate reading. So you could see the one on the left is at negative, it's kind of between -7 and -8. So I'm going to say it's -7.5. So x equals -0.75 is 1. And on the other end, I think that one is at 2.7. So that is my other one, or x equals 2.7. So they're my two solutions then. Now you're going to be given a little bit of leeway in this because, you know, plotting points is always a little bit inaccurate. So expect like a half square either way on the correct answer, but I'm pretty happy with those. Here's a right angle triangle, and it's got sides 8 and 10 millimeters on the two shorter sides. The shaded shape below is made up of two of these triangles. So it's got one sitting on top of the other. Work out the perimeter of the shaded shape. Give your answer correct to 3 significant figures. Okay. Right, now we know most of these lengths, don't we? So we've got the perimeter, and it's made up of this side here, 8, plus this side here, 8, plus the hypotenuse of this triangle that we don't currently know, plus this little weird wobbly bit here, and then 10. Okay, so we know 3 out of the 5 sides at the moment. Now that long side there, that hypotenuse, I can find, can't I, using Pythagoras theorem. C squared equals a squared plus b squared, where c is the longer side of your right angled triangle and a and b are the other two sides. Okay, so I've got a squared, which is 8 squared, plus b squared, 10 squared. What's that then? 8 squared is 64, 10 squared is 100. So then c is going to be the root of 164. Okay, now I could write out what the root of 164 is now, but I'm going to have to use it in another calculation. So I'm going to try and just maintain accuracy and leave it like that at the moment, because I don't think root 164 comes out to be a nice answer. Okay, so I'm just going to leave it as root 164 for now. Okay, and then let's see if we can work out this last little bit. So now we've got this side, we know this side we know is root 164. So the last thing we need to do is this little teeny tiny bit here. Okay, now if you think about it, that length there is the difference between the hypotenuse of our triangle, which we know is root 164, and this side of it, the side which is 10. So in other words, that little bit there is root 164 minus 10. Okay, so then the perimeter of our shape is going to be all those sides added up. Now we know what they all are. So I've got 8 plus 8 plus root 164 plus root 164 minus 10 plus 10. Okay, right, so what we've got there, I'm just going to cancel those off straight away. Minus 10, 10 cancel. I've got 2 lots of 8, so that makes 16, and I've got 2 lots of root 164, so 2 root 164. Okay, now at this point then I'm going to reach for the calculator and tap it in. 16 plus 2 root 164. That comes out to be 41.61. How do I need to round it off? To 3 significant figures. So to 3 significant figures then, that is going to be 41.6 then, isn't it? To 3 significant figures. Okay, so 41.6 millimeters to 3 significant figures. Question 6, ABC is a right-angled triangle. Work out the length of BC, given your answer to 1 decimal place. Okay, so here we've got sides of a triangle and an angle, and we want to find the length of another side. I think this is a job for trigonometry, isn't it? And for right-angled triangles, we're going to be using our 3 trigonometric ratios, which we can remember with the mnemonic SOHCAHTOA. Okay, so in order to work out which one of our 3 ratios we need to use, the easiest thing to do is just to label up the 3 sides of our triangle. Okay, so I have, well, the longest side is the one I usually go for first, so that's our hypotenuse there. Now this side here that's marked is adjacent to the angle, isn't it? It joins onto the angle, so this is the adjacent side, and then BC is on the opposite side of the triangle to the angle, so this is the opposite. Okay, now in this triangle I have been given the adjacent, and I've been asked to find the length BC, which is the opposite. Okay, so I wasn't given a letter, so I think I'm going to give it a letter. I'm going to call it X. Okay, that's the one I want to find. Okay, so I've been given the opposite. That's why I want the opposite. I've been given the adjacent. So which ratio has to do with the opposite and the adjacent and not the hypotenuse? Well, it can't be sine because that's got the hypotenuse in it, and it can't be cos because that's got the hypotenuse in it. It has to be TOA, okay, which stands for tan theta equals opposite over adjacent. So let's write down the full equation for tan theta. Okay, and then once we've got that down, it's just a matter of then plugging the numbers in from the diagram into the correct spaces in the formula. So tan theta, theta is the angle, isn't it? So theta here is going to be 56. So tan 56. Opposite is the side we want to find. I called that X. That's something I introduced. Okay, but it's all right. You can use letters if you want to. And then the adjacent then is the side I was given over there. It's the 12. Okay, so sub that in as well. Okay, then next what we're going to do is going to rearrange this. I'm going to cross multiply that 12. Multiplying both sides by 12 has the effect of shifting that divide by 12 on one side to become a times by 12 on the other. So I'm going to get 12 tan 56 is equal to X. At this point, I'm going to reach for the calculator. Just double check it's got a little d at the top, otherwise you're going to get the answer wrong. 12 tan 56. That comes out of my calculator to be 17.79. Now I need to round this to one decimal place, so that 79 is going to round up to 17.8, isn't it? So 17.8 centimeters to 1 dp. Okay. In part B, we're given triangle PQR, and this time we've been given an angle which we don't know, and we've been given two other sides, and we need to work out the size of the angle marked X, and again we need to give our answer correct to one decimal place. Now this is still a right angle triangle question, so it's still going to have to do with our three trigonometric ratios, SOHCAHTOA, TOA. Okay. Now this time I've been given, I want to find the angle X, but I've been given the angle that joins onto X, which is the adjacent. I've been given the longest side of the triangle, which is the hypotenuse. I've not been given, nor do I want to find the opposite. Okay, so that means I'm not really interested in anything to do with the opposite. So sine is out and tan is out. I think I want the cosine here. Okay, that's got to do with the adjacent and the hypotenuse, isn't it? Okay, so again, writing out the full equation for cos theta is equal to adjacent divided by hypotenuse. Okay, now again, I'm going to scan through the diagram and pick out the things that I need to put into my formula. So first up, the angle. Now the angle's down here. This time I don't know the angle, so I'm just going to say cos X. I'm going to switch to the letter that they've actually given me in the question. The adjacent, that is this side down here. That's the adjacent, isn't it? That's 15. Okay, and then the hypotenuse is over here. Look, that's 18. So cos X equals 15 over 18. Now we've got the cosine of X and we want X, so we have to kind of do the opposite of finding the cosine to cos X. Now the opposite of finding a cosine is the inverse cosine, so doing that to both sides will give me X on the left, and on the right I'm going to get cos to the minus 1 of 15 over X. Okay, and that is exactly what I need to type into the calculator in order to find X then, isn't it? Okay, so I'm going to get the cos to the minus 1 or the inverse cosine button. I need to press shift first before pressing cos, and you can see I then get cos to the minus 1 showing. I want to type in 15 over 18. I'm just going to use the fraction key. So 15 fraction key 18. Okay, I think it's good practice to close the brackets before you press equals. Mostly it doesn't matter, but sometimes it does, so I recommend just put them in. And then that comes out to be 33.55 and change, which to one decimal place I'm going to round up to 33.6. This is an angle, isn't it? So it's going to be degrees. 33.6 degrees to 1 dp. Question 27. Solve x squared minus 7x minus 18 is equal to 0. Okay, so we've got a quadratic equation here. I'm going to hope and see if it factorizes first, because that's a whole lot easier than using the formula. Now the constant on the end is negative 18. Just going to quickly find the factor pairs of 18 to see what pairs of numbers it might be. It could be 1 and 18, 2 and 9, 3 and 6, 4, no, 5, no, and we're back to where we've started from. So they're all the factor pairs. So it's got to be one of those pairs of numbers. Now if the number on the end is negative, it means one of those must be positive and one of those must be negative. Okay, now the middle term has a coefficient of 7 or negative 7. So can I make 7 out of subtracting one of my pairs from the other? So 18 subtract 1 has got a difference of 17. 9 and 2 have got a difference of 7. 3 and 6 have got a difference of 3. So it looks like it's this one then that's going to give me a number that adds to 7 then. Okay, so it's going to be, open a bracket. Okay, I'm going to have an x and an x. I'm going to have a 2 and a 9. One's going to be plus and one's going to be minus because I've got a negative number in the end. and I've got a negative number in the middle, which means the larger one of my two pairs has to be the negative one. So that has to be the 9 and that has to be the 2 there. Okay, so I've got x plus 2, x minus 9 is equal to 0. Now, if you've got two things multiplied together and they equal to 0, it must be that one thing or the other thing is 0. Right, so if x plus 2 is equal to 0, taking 2 away from both sides, you can see then that x must be equal to minus 2. Or if x minus 9 is equal to 0, then adding 9 to both sides, you can see that I've got x is equal to 9. Okay, so they're my two solutions then. X is equal to minus 2 and x is equal to 9. Now, if you do just want to check your work, you can tap those numbers back in, sub back in and see if you're correct. So for instance, 9 squared, if I replace x with 9, then 9 squared minus 7 lots of 9 minus 18, just checking that on my calculator, you can see that does equal to 0. And negative 2 all squared minus 7 lots of negative 2 minus 18, that also comes out to be 0. So yeah, I've checked it that way. It's a good way of quickly checking on your calculator. Question 28. In a sale, the normal price of a boat is reduced by 15%. The sale price of the boat is £272,000. Work out the normal price of the boat. Okay. Now, I said earlier I like to use this triangle FOM for doing percentage questions. The reason I like it is you can use it for every type of percentage question. So whatever it is, this one I think is a reverse percentage question, but it doesn't really matter. You just approach it the same way. So I'm going to draw my little triangle FOM, and then I'm going to find out what is the final, what is the original, what is the multiplier from the question. Okay, so going through the question line by line, in a cell the normal price of a boat is reduced by 15%. So this is a 15% decrease. So if I start with 100% and I subtract 15%, I'm left with 85%, which as a multiplier is 0.85. Okay, so that's my multiplier that I'm going to use. Okay, then the sale price of the boat is 272. Now we need to work out, is that the final or is that the original? Okay, so the sale, in a sale, the normal price, it started with the normal price, the percentage changed happened, and I ended up with the sale price. So the sale price is the final and the normal price is the original. Okay, so that's kind of how it works. So we're finding the normal price, so that is the one we want to find, and the sale price is the final, so that goes up here, 272000. Normally with these sort of questions, you just need to think about the tense, you know, like in, I mean, like not tense like camping tense, but tense is in the English tense, past, present, future. You'll find that when you've got these percentage change questions, one will either be in present tense and one will be in future tense, or one will be in past tense and one will be in future tense, or one will be in past tense and one will be in present tense. Either way, you can work out which one happens first, which is the original, and which one happens second, which is going to be the final. Okay, so in the past, the normal price, currently in the present, the sale price. Okay, so the sale price happens after the normal price. Okay, so that's the way we can tell which is which. Either way, we're going to cover up the thing I want to find, and that is the original, and the triangle tells me what to do with the other two. So original is equal to final divided by multiplier. Okay, and then just sub in those numbers in. So 272000 divided by 0.85. What does that come out to be? 272000 divided by 0.85. That comes out to be 320,000. 320,000. So that is my original price before the boat went on sale. Okay, we are done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.